Okay, let me continue with the later part of the Python primer. So before this course, we were doing some examples with the Python primer, like the list and tuple. So let's continue with the string. Okay. The string class is also very important to understand. It's advanced. Okay. The str class, it can be enclosed with the single quote or with the double quote. Yeah. So it's very unique. Okay, in any other programming language, you need to use the double quote, but in Python, you can use single or double to express as the string. And also, you can do with the 3 single or 3 double quotes if it contains new line. Okay, let's see. So I'm using this print with 3 double quote. So this is the example of string. You can type any text in the multiple lines, and then you will close with the 3 double quotes. So as you can see, we have 3 lines. The third line is nothing is blank, but we have 3 separate lines because of these 3 double quotes. If you want to use like yeah, before you do this one, can I have print with the single quote? Okay, let me have half. Yes, you can just give the string with the single quote. The next is about set. Set is a kind of collection of elements, and the elements in the set should be without duplicates and without an inherent order of those elements. So those are the properties. Okay? No duplicate and no order. Only instances of immutable types can be added to a Python set. So the objects such as integer, floating points, and character strings are eligible to be element of set. Yeah. We have another kind of class which is frozen set. The frozen set class is an immutable form of the set type itself. Okay, I guess you already know the difference when you learn the list and tuple. List is mutable, tuple is immutable. So you can change the value, but in the tuple you cannot change the value. The same with this one. In the set, you can change the value, but in the frozen set, it is immutable, so you cannot change the value. It's unchangeable. And set is expressed with the curly braces. Okay? The curly braces is to indicate, okay, maybe I will explain one more time. If it is the square bracket, what is the square bracket? The square bracket is a list. If it is the parenthesis, the bracket, the general bracket, it is a tuple. But when we use the curly bracket, it is a set. Let's say I have 17. It is 17. Red, green, blue. It is the set of color. Okay. The exception to this rule is that the empty set does not represent any empty set. Instead, the constructor set returns an empty set. Okay. So please remember, this is not empty set that you already know from the empty list and empty tuple, but this is not the case. So let's see, how can we apply the set? So we have the set here. I would like to know if the element on the set A, B, B, C, okay. So if it is a set, then the result will be A, B, and C. Why? because there are two properties inside. First is it is no duplicate, without duplicate, and the other is no order. Okay. Yeah, this is just a coincidence because we start with A, B, and C, so it is in the order A, B, and C. Okay. Next is about the dictionary, DICD. So when we are doing with the dictionary, it is a class that is similar to what we know the dictionary. It has a key and values. Okay. When we have the key and value, yeah, it is almost the same with the set. Okay. Because the key should be unique. The key has no duplicate. The key cannot be associated to the same key. So we have the same literal form, which is the curly bracket, and this literal form with empty bracket, which is empty dictionary. Okay, before, if we have nothing inside of the curly bracket, it represents nothing. But here we have the empty dictionary. So the non-empty dictionary is expressed using the comma separated series. So you need to make the column key column value. Okay, this is important. Okay. When you have the key and value, okay, you need to separate those two with the colon. And for example, the dictionary GA colon Irish, DE colon German. So if we want to know what is the value of GA, then the result will be Irish. If we want to know what is the result of DE, then the result will be German. So it is a mapping function that the GA will be regarded as Irish and DE will be regarded as German. Alternatively, the constructor accepts a sequence of key value pairs as a parameter. So it is like the dictionary pairs. Okay. So if it is a list, then it is, yeah, we have a list, and inside of the list we have tuple of two value, and there is also a tuple of two values. Then when we want to create a dictionary, it will automatically generate the key value pairs. Okay, for example, let's see. I want to check this on this dictionary GA Irish and DE is German. So if you want to see the dictionary, okay, the result will be the GA Irish and DE German. If I want to know the value of GA, then you can call dictionary 1 and call only the key. So when you call the key, then you can see that it is the result is the value of GA, which is Irish. So in the slide that I show you that we can also combine the list and tuple into the dictionary. Suppose I have a list, and in the list I have the value GA Irish, DE, and German, and I put it into the variable pairs. So after I have this variable, I want to call the dictionary and let the parameter equals to the pairs. So now we have the value GA Irish, DE German according to the pairs. Okay. The next thing that we need to understand is about expression and operators. So in Python, the expression is very easy. It's not that complicated like the other programming languages. It is only the combination of expression with the special symbol and keywords, and we can say it as operators. So the semantic of an operator depends upon the type of its operand. For example, A and B are numbers, so the A and B indicates addition. But if A and B are strings, then the operator plus indicates concatenation. Do you know what is concatenation? So the addition means the mathematical addition, and the concatenation means just adding string and string. Okay, before I continue with the Python, we need to know the logical operator. Oh, okay, maybe let's go to the the expression and operators. Okay, so in this expression and operators, yeah, I have this one, 3 plus 5. It gives you 8. How about hello plus world? Okay. It is a concatenation. So it is a combination of hello and world. So if I want to know hello is greater than hello, okay, you can see it is true. Why it is true? So surprising, right? So in this case, the hello, it's the small h is greater than hello, the big h, because it is depending on the ASCII character. Okay, what is ASCII character? Yeah, the ASCII character is related with the standard number in computer. So the standard number in computer, they have the value, so it will represent that the big character will come first and the small character will come later. So the number of small h is bigger than the capital H. So is true. So you can see if it is a sequence A, B, C, D, E, F, the mathematical operation will perform as the true and value basis. So A, B, C is less than D, E, F. Yeah, of course, A, B, C is before D, E, F, then it is true. In Python, we can have the keywords operator for Boolean values like not, and or. The and or operators are short circuits in that they do not evaluate the second operand if the result can be determined based on the value of the first operand. So if you already know what is the value of the first and it is true, then the other will follow according to the value. Equality operators, we have to support the following operators to test two notions of equality. So is, you want to know whether they have the same identity. Is not different identity. I mean, if you put the equal, it is related to the equivalent. If the symbol is exclamatory and equal, it is not equivalent. So the expression A is B equals true precisely when identifiers are A and B are aliases for the same object. The expression A equal B tests more a general notion of equivalence. Okay, so let's see. Oh, I already gave this one. No. Okay, maybe I will explain more about the logical operators and the equality operations later when we deal with the if and with the loop section. Okay. So the comparison operators, yeah, you may know this one: less, equal, greater than, and greater than or equal to. Okay. This is the natural order. And these operators have expected behavior for numeric types and are defined lexicographically, case sensitive for strings. So I already show you the examples. If it is string, so it is based on the ASCII number. If it is capital, then it comes first. And if it is lowercase, it comes later. So the number of the small letter will be higher than the capital. In the arithmetic operators, you may know some basic operation like addition, subtraction, multiplication. Yeah. And it depends on the operand. If both operands have type integer, then the result will be integer. If one or both operands are having a float type, then the result will be float. Okay. So you can distinguish between true division and integer division. Okay. So the true division is always a type float, but the integer division is always integer with the result is truncated. So we have addition, subtraction, multiplication. true division, integer division, and the modulo operator. Let's check. What are they? We have 5 divided by 3. It is 1.666666. Okay, what about 5 divided by 3 with double slash? So we call this is the integer division because I want to get the integer value. But the first division is the real division. I want to get the real value. What about the modulo? The modulo is to get the remaining numbers. So 5 divided by 3, there are remaining 2. Okay. What about if I combine between the integer and the float? Okay, so the integer is 2 plus float 3.0. So the number will be float. If I float multiply with integer, then the number will be also float. Okay, bitwise operators. So these bitwise operators is also one of the basic Python primer. Okay, in the bitwise operator, it will compare the values according to the bit number. Okay. Maybe it's a little bit complicated to explain. So let's see the example. I give you one example about the bitwise, like this one. Let's say I have a equals to 60. It is a number, okay? And in this number 60, actually, it is a bitwise of this one, 0, 0, 1, 1, 1, 1, 0, 0. And I have b is 13. So the 13 is having a bitwise like this one, 0, 0, 0, 0, 1, 1, 0, 1. And let's make c equals to 0. Okay. So if I want to make a bitwise a and b, then the result will be something like this one. If you want to make a bitwise a line horizontal b, then the result will be this one. So it depends on the bit operator. Okay. When you want to use this bitwise operator, then maybe it's related with the machine language. If you are interested with this machine language, then you can try to figure out more for those one. Okay, so this is the bitwise. The sequence operator. Okay. When you have the string, when you have tuple, and when you have list, it supports the following following operator syntaxes. So if you want to see the particular index, then you can just use the square bracket, and J represents the number you want to see the particular index. If you want to know some values from start until stop, then you can use the start as an integer number and then separate it with colon, and then you can mention the stopping number, or this is the stopping of the index. You can also do with the step. It means if I want to check the start until the stop for every 2, then the step can be 2. By the default, step is equal to 1, but you can set the step. If you want to step equals to 3, step equals to 5, then you can define it like that. S plus T, it is a concatenator of sequence. So if you have 2 lists, then you can just concat 2 of them. K multiplied by S. So if I have an S, which is a tuple or it is a list, and you want to multiply with K, K is a number. Okay, so it means you want to multiply a particular number with the numbers in the S, then it means K will be multiplied with the element in S. If you want to check any value, whether it is in S or not in S, then you can use this one. Let's see. I have this one. Okay. And I want to check the list in index 1, which is 1. Okay. So I want to check the list in index 1 until 3. So it means I want to see the elements in index 1 and 2. Okay, number 3 is included. Okay, so the 3 will be only the limit. So you can see we can only show the element index 1 and 2. Okay, let's suppose I have this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's at least 2. So if I want to know the number from 1, which is the starting index, until 9, which is the ending of the index, so it is from 2 until 8. Okay, and I want to check for every 2 steps. So it shows 2, 4, 6, 8. And if I want to add the list 1 and list 2, okay, so you can have 1, 2, 9, 9, 9, 9, 7, 1, 2, 3, and so on. If a particular number or a particular scalar number multiplied by the list, so I have list. What is list 1? This one is 1, 2, 9, 9, 9, 7, and I want to multiply into 3. So you can see there are 3 times 1, 2, 9, 9, 9, and 7, 1, 2, 9, 9, 9, and 7, and 1, 2, 9, 9, and 7. I want to check if 2 is in the list 1 or not. Oh, sorry, it is list 2. Oh yes, it is true. I want to check if number 3 is in the list 1 or not. It is false. I want to check if the number of 3 not in this one. Okay, it is true. Okay, so that's the easy way to go with the containment. The sequence comparison is also another thing that you need to learn. Okay. The sequences define comparison operation based on the lexicographic order, performing an element by element comparison until the first difference is found. So, for example, I have these 2 lists, 5, 6, 9, and 5, 7. So we will check this one. Okay, what is the result of 5, 6, 9, and 5, 7? So 5 and 5. Is it true? Yeah, we are not sure, but we will check because it's the first difference. 5 and 5 is not equal, then it's not equal. Okay. So let's see. It's not equal? Yeah, it's not equal. If you can check this one, then it is 5, 6, 9 is true. Why? Yeah, because we can check this one 5 and 5. Yeah, it's not true, but the 7 is 6 is less than 7. Okay, so they check based on the based on the element. If it is not true, then we will check the next element. If there is a true, then they will return true. Okay. So another sequence comparison like equivalent, not equivalent, less than, equal to, greater than, equal to. Yeah, you can try by yourself. So the operator for sets, you can use key is in S, or key is not in S. So basically it's the same with the previous one. And you can use equivalent, not equivalent. And you want to check whether it is a subset or it's a proper subset or superset or proper superset. And okay, we have union, intersection, and also the set of the element S1 but not S2, and the set of element precisely one of the S1 or S2. Okay, so let's see how can we do this one. Okay, suppose I have S1, S1 to 3, and I have S2, S3, 4, 5. Okay, so the S1, S2 with the vertical line, what is it? The vertical line means the union. Okay, the vertical line means the union. So I want to know the union of S1 and S2. So the result will be 1, 2, 3, 4, 5. 3 is the intersection. So they will automatically disregard this one. S1 and S2. So I want to see the intersection between S1 and S2. Yes, the result is 3. If I want to know the S2 minus S1, so the element which is in S2 minus the element of S1, then it will be only 4 and 5. Why? Yeah, because what is S2? S2 is 3, 4, and 5. What is S1? S1 is 1, 2, and 3. So let's minus the element in S2 with the S1, and you know that the S1 has 3, and in S1 has 1 and 2, which is not available in S2, then the result will be only 4 and 5. Okay. The result also will be different when you use the head, S1 head S2, so the result will be S1, 2, 4, and 5. Okay. So by using this one, I can only get the value which is not included in the intersection. Okay. Operator for dictionary, yeah, basically it is the same with the list. So you can see the key. What is the key? If you use list, the key is the index number. So number 1, number 2 is representing the index, but in the dictionaries you need to call the key, and you want to set the key something related with the value, or you want to delete or remove the key, and you want to check whether key is in the dictionary or not in the dictionary. And you can also check the dictionary 1 whether it is equivalent with the dictionary 2, or the dictionary 1 is not equivalent with dictionary 2. When you do with the operator, you need to understand this operator precedence. So this operator precedence represents that what is the first priority and what is the lowest priority. So the first priority is the access, the member access, and the next is the function and so on, and then it goes down to exponentiation, unary operators, multiplication, addition, subtraction, and so on, until the lowest one is the assignment. Okay, so I don't know whether you need this operator precedence or not, but at least you need to understand that this has the precedence rule. So if you are trying to combine some of these operators and maybe the result is not the same with your expectation, then maybe you need to check this operator precedence for the correct answers. Okay, I think that's all for the Python primer version number 1. I will continue with the Python primer number 2 after this video. Okay, thank you very much. Keep joining with this video and don't forget to subscribe.